So we're asked to prove that the right side of the equation equals...
We're asked to prove that the left side of the equation equals the right side of the equation. So left side's in red here. First thing you need to do is see that there's two terms on the left, there's one term on the right. So you've got to be able to combine these two, and the only way to do that is by getting common denominators here. So I've taken the top equation, the top expression, and I've multiplied both sides by 1. In black here is 1. It's just in the form of 1 plus cosine of x over 1 plus cosine of x. And I did that so I could get common denominators. If you multiply the bottom by the opposite's denominator, you're guaranteed for them to be in common. So let's see what that looks like. That's supposed to be a minus down here. But yeah, now that we've got common denominators, now we can add straight across the numerators. So we're going to take this and add this to it. 1 plus 1 is going to give us 2. We get cosine of x plus a negative cosine of x. That's going to cancel out. So we got 2 up top. So we still don't have what we were seeking to prove. We don't have 2 cosecant squared x. So let's try expanding the bottom a little bit. Let's multiply this out. So you might have heard of the FOIL method. You'd multiply the first, the outside, the inside, the last. Whatever method you have, multiply those out, and you should get 1 minus cosine squared x. And that can be rearranged as well, because if you use your identities, sine squared x plus cosine squared x equals 1. Or put it another way, sine squared x equals 1 minus cosine squared x. Okay, so this down here, that bottom is sine squared x. And then that's all over underneath 2. And another way of stating sine squared x is that sine is 1 over cosecant. So this is 2 cosecant squared x. And that's what we were looking to prove in the beginning. So there, those steps represent the proof.